Okay, this is chapter 2, number 7, and the question states a position time graph for a particle moving along the x-axis is shown in figure 2.7. On part A, it says find the average velocity in the time interval t equals 1.5 seconds to t equals 4.0 seconds. Part B asks to determine the instantaneous velocity at t equals 2 seconds by measuring the slope of the tangent line shown in the graph, which is right here, that green line. I don't know if you can see it. And part C asks what value of t is the velocity 0. So we're going to start with part A, and we're going to be using this formula: average velocity equals distance final minus distance initial, that's the top part, over time final minus time initial. So that's our equation. So let's define these variables. Our final, or our initial time, is 1.5 seconds, and our initial position, x, is 8.0 meters. And then our final time is 4.0 seconds, and our final position is 2.0 meters. So now we plug in these values into the formula, and that is 2.0 minus 8.0 meters over 4 seconds minus 1.5 seconds. And this comes out, when you type it into your calculator, comes out to negative 2.4 meters per second. That's the answer for part 1. Okay, for part B, it says to determine the instantaneous velocity at t equals 2 seconds by measuring the slope of the tangent line shown in the graph. And that is this green line right here. And we're going to be using the slope formula, rise over run. And our rise is actually negative because it's going down. Our starting point is 13.2. It's just a little bit above 13. And it's going to be negative since it's going from high to low. So that's negative 13.2 meters for the rise, and then for the run it's going from 0 to 3.5. So that would be 3.5 for our run, and then you type that in your calculator and you get negative 3.8 meters per second. Okay, part C asks at what value of t is the velocity 0. So we can look at this given graph that it's starting at around 11, and then it's moving down to about 2 meters, and once it gets to 2 meters it's slowing down and stopping and going the other direction. So let's say this ball is the object. It starts at 11, goes down, and then stops at 2, and then goes back the other direction. And the way we look for this answer is we're finding what point it's going and stopping. And on this graph it shows right here at point B. That is that point. And so the velocity is equal to 0 at time equals 4 seconds. This is chapter 7, or chapter 2, question number 7. Thank you for watching.